there's two problems in the speed of light. And, they say that you have Einstein on one hand, through special relativity. He had this principle of special relativity. One of them says that light travels at a constant speed, okay, through the vacuum. Let's clarify that. Through the vacuum, light travels at a constant speed. Speed is 300,000 kilometers per second, rounding off. Okay, and no one can live with that. And to this day, we're talking about 100 years later, people say something else. They talk about faster than light. They talk about tachyons. You've got what? The Enterprise. It travels much faster than that. It travels at warp speed. What is warp speed? It's the speed of thought. You think you're on the other side of the universe and you're there. And you say, well, okay, that's Hollywood, that's science fiction. No. Believe me, they're talking about, again, tachyons, so they ponder those things. They talk about phase shifts within light. They sneak it in any way they can. And so even though on the one hand they say light travel, that Einstein proved mathematically, et cetera, that light travels at 300,000 kilometers per second and it doesn't travel faster or slower in vacuum, they overrule that. To this day, they keep overruling that, and they want you to believe that, theories can be overruled. So Einstein's a hero, but then we overrule him anyways because we want to travel faster than light. Why do we want to travel faster than light? Because otherwise, NASA, European Space Agency, Japanese Space Agency, all these agencies are dead. They're dead because there's no way we can reach the nearest star. Proxima Centauri, 4.3 light years away, round trip, close to 9 years. We can't go to the nearest star at the velocity of light. We got to improve on that. And we're billions of years away from that speed. In fact, Einstein said you can't travel at the speed of light because you become energy. So we got a problem because on the one hand, they give, they bow down to Einstein, okay? And they say, oh, Einstein, he was so great. He discovered, among other things, this constancy of the speed of light. And then on the other, they say, by the way, we're going to overrule him. We're going to throw all that away because we need to make people believe that you can indeed travel faster than light. And the question is, why can't you? Because, particles travels faster at the speed of light, right? Okay, fine. Why can't they travel faster? What's the physical impediment? Okay, so that's what we're going to be looking at. And we can trace it to two problems. Okay, the first problem is language. Mathematical physics thrives on irrational language. And the second problem is the word object. Mathematics has no use for objects, so they never worried about defining the word object in a scientific way. And they use the informal version, which is an irrational version, which is the one of ordinary speech, which is the see-touch criteria. Okay, if you can see it or touch it, that's an object. Okay, and so that brings in experiment because experiments can only be done on things that you can see or touch. And the invisible stuff that serves as mediator, like for gravity, magnetism, well, we're going to put particles in there. Particles, and more particles. It's all done with particles. And when you say, well, the explanation is irrational, I say, well, that's philosophy. That's more or less what we have today. And so we have two problems. And the main one, at least the starting point, is language. We have a problem with language. And so here we have one fellow, and he says the following. He says, saying that plasma is not an object because you have to ionize gas first is like saying that steam is not an object because you have to boil water first. Plasma is what? Charged particles with separation, not separated, just like steam is water molecules with separation. God can create a cloud of steam without first needing to create water and boil it. I don't know who it is you think keeps claiming that plasma involves motion, but they are feeding you baloney. All substances look solid when you take a freeze frame. Well, so many errors. Absolutely so many errors. Let's go with the first one, and that's that steam is a concept. There is no physical object called steam. Sorry. Okay, again, you're using the language of ordinary speech, okay, the one mathematics has taught you. And so people just follow this this language that mathematical physics has, and they go with it. And we're challenging that language, okay? So here you have steam, okay? Steam, what is steam? Steam is water in the gas phase, okay? Due to evaporation or due to boiling, where heat is applied. That's Wikipedia. Dictionary says more or less the same thing. Steam, water in the form of an invisible gas or vapor, changed to this form by boiling, okay? So what is steam? Steam is boiling water, hot water, okay? You have to have the hot in there. Whenever you have an adjective in front of a noun in physics, okay? In science, not in ordinary speech, okay? Let's get that straight. Whenever you have an adjective in front, or an adverb for that matter, but that's in front of a verb, right? Whenever you have an adjective in front of an object, a noun of physics, only objects can serve as a noun in physics. You have an adjective in front of a noun. Always, 150% of the time, it's a concept. Okay? There is no such thing as a black cat in science, in physics. There's a thing called a cat. Okay? No such thing as a black cat. Black cat, concept. You're already comparing something. Okay? And same with steam. Steam, if you just point to a freeze frame, you call it gas, vapor, you want. Okay? But that thing you're looking at, steam, is not steam. It's gas. Okay? Now, if you want it to be steam, you got to have it moving. Okay? So let's get that one first in there. Okay? And here's the other issue. We talked about ions there. What is an ion? Well, it's a gas that's been, where you take an electron out of the atom, essentially. Okay? That's what it is. So what is it here? Well, when you look it up, you find that every time you look at the word ion, you find all these processes. They're all in motion. They're called ionization. And people say, well, ionization is not an ion. Well, you're wrong. You're wrong. Ionization and ion are synonyms. Okay, there is no physical object called an ion. Okay, let's get that first before we move to plasma. Okay, so here we have an ion, a particle, atom, or molecule with a net electrical charge. Electrical charge. What is charge? Well, charge is something in motion. In fact, the value on charge is 1.6 times 10 to the minus 19 coulombs. And what is a number? Number is something in motion. Okay? Counting. That's what number is. So if an ion has something to do with charge, electrical charge, again, a adjective, we got a problem because it's a concept. Okay? And so that's the first thing you got to absolutely understand. Ion, an electrically charged atom or group of atoms formed by the loss or gain. Loss or gain are both verbs. Okay, I know this is news to you. Loss and gain are both verbs. Okay, so there's motion already embodied in the definition of ion. Okay, more fundamental than that. If you can define the term, it's a concept. Okay, in science we do not define objects. In science we point to objects and name them. Table, chair, light, lamp, whatever. You can't. You don't define objects. You point to them. Okay, in physics. In religion, that's something else. Mathematics, ordinary speech, we don't care about any of that. In physics, you have to point and name. Okay? So if you can define the word, 100% of the time, it's not an object, it's a concept. Okay? Okay, so it says the word ion was coined from the Greek ion. A cation, right, is something that moves down, and an anion is something that moves up. Move. Okay? It's moving. Loss, gain. Okay? Ions are formed by the gain or loss of electrons, okay? And atoms can be ionized by bombardment with radiation or the transfer of electrons between atoms and molecules. So, yeah, if what is plasma? Plasma is ionized gas. Then it has, the word plasma is already, it already embodies motion. That's different than gas. Gas does not embody motion, okay? I can point to gas, and the word gas does not contain any motion, intrinsic motion in it. On the other hand, the word plasma, there is motion embodied in the word, in the definition of the word plasma, because it's being ionized in the photograph. That's what you're saying. You're saying you can take a snapshot of plasma. No, you cannot. If you take a snapshot of plasma, what you have is gas. Okay, and you say, well, but it's ionized. What do you mean it's ionized? You mean something happened in the photograph? You removed an electron? Is that what you're saying? It's charged? So no, the word plasma embodies motion just like the word steam embodies motion, just like the word ion embodies motion. Okay? And yeah, it's very hard for some of these people, especially from the electric universe, to understand that. Okay? So here we have hydrogen atom. If you ionize it, you don't get an ion. What you get is proton. Proton is an object. An ion is not an object. Okay? An ion is something that happened to an atom. Okay, and I don't know how else to get that through to you. Again, you got to use a little more intelligence, but if you don't have the intelligence, well, I can't help you. Okay, here's, again, the difference between gas and plasma. Gas you can take a picture of. Okay, I don't need to have gas moving in order for it to be gas. Plasma is something else. Plasma, you need to remove the electron from at least one atom for it to be plasma. Otherwise, it's not plasma. Okay, if I freeze the universe, all those electrons move back probably to their atoms. If I stop the whatever influence the gas is under. Okay. You have to do something to the plasma, and the word plasma already embodies motion. And unless you get that through your thick skull, well, you'll be a follower of the electric universe. That's how bad it is. Okay, so yeah, anyone dealing with the word plasma is, cuckoo in the head, mentally retarded. Okay, we treat all people who use the word plasma as mentally retarded here. Okay, and again, it's all these people from the electric universe. Okay, another fellow. He raises this issue. He says, Maxwell described light as propagating wave of electric and magnetic fields. In mathematical physics, he calls it physics, okay? A field is a quantity. What is it? It's a quantity. Is a quantity a physical standalone object? No, quantity is a concept. Okay, there's no physical object called quantity. He's saying, these are his words. He got this, okay? He's right, but I'm just saying that these are not my words. These are his words. Represented by a number. What is a number? A concept. The word number means to count. It's a verb, not a noun in physics or for the purposes of science. In ordinary speech and mathematics, they think number is a noun. It's not a noun in physics. In physics, number is a verb, the verb to count. Okay, so if it's a quantity or a number or an amount, we don't care. Concepts, dynamic concepts, counting. Okay? That has a value. What is value? A concept. For each point in space and time. He's right. That's the definition of the word field. A value at each point in time. You see it there at the bottom. And we have values, numbers, and they make these numbers vibrate. Very scary stuff. Field starts vibrating, all the numbers start vibrating, and it usually goes from stronger to weaker as you go out farther away from an object, whether it's an electrode or whether it's the earth, the gravitational field. It gets weaker as you go out. That's the notion of field. What are they talking about? They're talking about the values of the strength of the field at each point in space around an object. Okay, so he's got it right. That's the definition for the word field. If you can define it, it's a concept. There's no physical standalone object called field. Okay, and it says this has led physicists to consider electromagnetic fields to be a physical entity. He says, physical. Well, we need to determine it's a physical entity or a concept. Is it an object or is it a concept? Can't be both. Concepts we define, object we point to. Objects have shape, concepts don't. So God cannot be both a human figure that creates the universe and also love or intelligence. No, God cannot be a concept and also a physical object. He's got to choose. And he can only exist if he's a physical object. If he's a concept, he doesn't exist. And nevertheless, is that what you pray to? You pray to a concept? Hopefully the concept has an ear to hear you, Okay, so yeah, we got a problem with language. That's my point here. This language, as you can see, comes from reifying these concepts into objects. Okay, they convert concepts into objects. They talk about field, they talk about energy, they talk about mass, and everybody thinks they're talking about physical objects because they say phrases like transfer energy. What do you mean you transferred energy? How do you transfer a concept? They transferred information. How do you transfer information? Did you carry it with your hands? How do you transfer information? What have you how does it transfer information move? So they talk about sending information at the speed of light or whatever. Nonsense. That's mathematics. In science, we don't transfer information. It's very scary stuff. Okay, don't ever do that. Okay, so the problem is language. And here, let me show you a little story. Okay. Here you have Martian. He comes to Earth. Okay, and he looks like that cat there. Okay, and what does the cat do? Felix, he revolves this mass, and he does it with so much energy, rolls it around, throws it, and breaks the window with force. That's more or less how a mathematician explains a physical interpretation. Explains how the window broke. So the window broke because what? Mass was thrown with so much energy that the magnitude of the force shattered the glass in 1 picosecond. Those are the concepts they use, and they say, we explained it. They explained it. They explained the mechanism of how the window broke. No, I don't think so. I don't think that's an explanation. Let me show you how a physicist does it and how the language is totally different, okay? And this is how we do it in science, okay? And the language of physics is illustration, not mathematics. And we say that the window broke when a horseshoe went through the glass, okay? And I hope you can see the difference. There is a little bit of difference, qualitative difference here, okay? In one case, they're throwing concepts around which they reified. And in science, we don't do that. In science, we have to explain how the window broke, okay? So this is the first issue. Okay, hopefully that became clear, okay? And what's the issue? The issue here is language again. Okay? That's the major problem. And here, let me surprise some of these people. And I know I'm going to get a lot of feedback, it's called, for this. These are the verbs, concepts that people mistake for objects. Steam is a concept. It's a verb. Okay, it's boiling. You don't concentrate on the word water. You concentrate on the word boiling. Okay, that's what steam is. Wind, it's moving air. Okay, so is a tornado and a hurricane. All those are moving air. The object is air. Okay, and you're moving it, and then we call it hurricane. Under this circumstance, tornado under that one, if it whirls around or whatever. Vortex, no such physical object as a vortex. When you take a snapshot of a vortex, you get a cone, usually an ice cream cone. Okay, plasma concept. Okay, it's a dynamic concept. You have to ionize almost every atom in the soup. Okay, that means the electron has to be removed from the atom, okay, in order for it to be plasma. And you have to be doing it, and you can't do it in a single frame, obviously. Okay, so if you're doing it, you got a verb there, you got a movie. Plasma is a movie, always a movie, because you're doing something to the atom. And again, electric universe people have tremendous mental barriers to understand the language, and that's what we're talking about here. Language. You got to get the language straight before you can do physics. These people never do language. They consider that a job for English majors, maybe librarians. That's why they don't define words. They look them up in the dictionary and say, well, let's see what the dictionary says. Well, we don't have a single definition worth anything for science or for physics in the dictionary. So don't look at the dictionary, because they're all the words have been misdefined for the last 10,000 years. And yeah, gas is a physical object. On the other hand, ion is not a physical object. An ion is what? A concept. Ion means that you're removing an electron from an atom. When you do so, at least for the hydrogen atom, what you get is a proton. Proton is a physical object. Because you can talk about that ball in the center. We'll even take the quantum version, no problem. But if you're going to talk about that ball in the center, that's a physical object. We call that a proton. When you put the electron back in, we call it an atom. As is, okay? We have problems with going around, but because it's a composite object, okay? So it's not really an object, but when we talk about atoms constituting molecules, we treat them as objects. Ion is something else. Ion means you're going to do something to the atom. Plasma, you're going to do something to the gas. Steam, you're going to do something to the water. Wind, you're going to do something to the air. When you do something, it's a concept, dynamic concept, it's no longer a physical object. Like I like to say, a jumping kangaroo is not a physical object. The object is known as kangaroo. Okay. Okay. Here's some other words that let me put over here, that we usually mathematical physics reifies. Electricity. There's no physical object called electricity. Sorry. Electricity is a verb. It's a concept, dynamic concept, in fact. And when I tell that to the people of the electric universe, they say, well, why don't you put your fingers in an outlet? You'll find out if it's an object. And that's not how we determine objects in science. In science, we define the word object, and if it meets the definition of the word object, it's an object. Otherwise, it's not. See how easy it was? But you can go ahead and put your fingers in there to try to prove that electricity is an object, okay? And what's funny about the electric universe, they never define the word electricity. They've given up on that, as I've shown in the past, and they say it's an undefined word, but let's continue. You know what we're talking about. That's the way they put it. And electric is in the title of electric universe. And then they even worse, they say that all galaxies are interconnected by these filaments. How can they be interconnected by filaments if the atom of the electric universe is the planetary model, and electricity, according to them, is this flow of electron beads from atom to atom? How do you create continuity with a little bead going from atom to atom? How do you create these filaments? So they have a contradiction because they want to say that the filaments unite or hold together all these objects. And it turns out when you go to the nitty-gritty, all these filaments are made of atoms, and the atoms are all planetary atoms with the beads going from one electron, from one atom to another, right? And so when you have a flow of these beads, how do you create this rope, this filament that pulls everything together? You're building something continuous with discrete parts. You can't do that. Not in science. It's irrational. Anyways, time, force, mass, energy, wave, charge, number, all of these words are concepts, they're verbs, okay? Displacement, perturbation, and so on. So you can't use this as nouns. You can't use them as objects, which is exactly what mathematical physics does. Okay, and just in case, here are the adjectives and adverbs, okay? Shape is an adjective, okay? It's a qualifier of a noun called an object. Objects are, shape is a property, a qualifier of object. So shape, anything related to shape, is an adjective. Okay, sorry, I know you learned that this is a noun, not in physics. Okay, so you got to learn the language of physics in order to be able to give physical interpretations. Straight, okay, people confuse it with rectilinear. They say, I traveled straight. That's in ordinary speech and mathematics, not in science. In science, you travel rectilinearly, okay? And you can say rectilinear travel, whatever. But the point here is that straight is an adjective, rectilinear and rectilinearly are adverbs. Rectilinear can only be motion. Same with curvilinear versus curved, bent, and warped. Okay. Location, angle, perpendicular, all those are adjectives. Those are, they tell you it's a property of an object. There is no physical standalone object called perpendicular. Therefore, there is no noun in physics called perpendicular. Okay? You can't talk about perpendicular as the subject of a sentence, not in physics. The subject is whatever object there is, and perpendicular is what it does, or actually in the case of perpendicular, how it's positioned. Okay, so it's a static concept, therefore it's not an adverb. Okay, so all these words you got to relearn them. Forget about ordinary speech. Forget about mathematics. These are how the words are used in physics for physical interpretations. Okay, direction, matter. What is matter? Objects that exist. What does exist? Exist is an adjective. It's not a verb. You don't begin to exist in physics. Physics, an object that has location, location being a static concept, okay? Object has no motion, the word object, embodied in it. So an object with location is what is exist. And all you're doing is qualifying the object. Okay? So exist is an adjective. And so on down the line. So you got to learn these terms for the purposes of physics. Sorry if your religion says something different, okay? But that's how we're going to use these words here so that you're in tune with what we are saying here, okay? Okay, so now here comes the Martian again. We had the cat, right, a little while ago throwing the stone through the window. This time we have a Martian, okay? He comes and visits us, okay? And he waves his hand, okay? And suddenly a window breaks, okay? And you say, how did he do that? And, I mean, did he use magic? Is he using spirits? He just waves his hand and from afar and suddenly the window breaks. How could he have done that, okay? And what is the issue? Well, the issue is that maybe he's not using magic. Maybe he's using something that you can't see. And it turns out, you ask him and he explains, look, I did it with a rock. What do you mean a rock, a stone? I don't see anything in your hand. I just saw that the window broke. And he says, well, it turns out that, you know, I did it with a rock, but you can't see the rock because what happens is that this rock gives off ultraviolet radiation. And you can't see, you earthlings, you cannot see an ultraviolet light. And that's why you thought it was magic. But if the guy, you know, makes it appear like he just draws it or shows you the movie, maybe a special movie that comes from Mars or wherever, right? And he shows you what he actually had in his hand, well, then it's no mystery. Then it's kid stuff. But see, while you couldn't see the stone, then you thought it was magic. You thought the guy was just throwing, you know, nothing. He just waved his hand. That's as far as you're concerned. And so why am I bringing this up? Well, we have this situation with light, and especially with the velocity of light, okay? You can't see the mediator of light. In fact, you know, here you have magnetism. You can't see the mediator of magnetism, okay? You don't see anything between these two, but it causes some magic, some incredible magic, pulls these two things together. Here's another magic trick, okay? I let go of the pencil, falls to the floor. You do it many times, you'll find out it always falls to the floor. And so what's the issue? The issue is that you can't see the mediators. And so you got two choices, okay? You either say that there's nothing there, no mediator, or, you know, meaning you do it with spirits. Because if there is no mediator, what you're telling me is that pencil falls always to the center of the earth, and one magnet attracts another. simply because either there's ghosts and spirits, or you're going to introduce black magic. You're going to say, ooh, two magnets come together. Is that what happens? Or is there a physical object that you can't see or touch? Which one is it? So, you have the materialists that say there's a physical object in there, I just can't see or touch it. And you have spiritualists, which is 99% of humanity probably out there, that says, oh, there's nothing there. It's spirits. And because I can't see or touch it, there's nothing there. Those are the two choices. And of course, most of humanity just believes there's nothing there because you can't see or touch it. And that's our daily experience, that you got to see and touch something for it to be a physical object. And that's easily solved. We redefine the word object so that it doesn't include see or touch. Okay? We say that an object is that which has shape. Okay? And so here are some examples of quantum mechanics where, because you can't see or touch the objects, okay, they've come up with, let's see. There we go. Here we have entanglement, okay? And so what happens here? Well, you're saying that one object influences the other object with nothing in between them. Called entanglement. They call it Einstein-Podolsky-Rosen, the EPR test. And what they say is that one ball affects the other one goes clockwise, the other one counterclockwise, and vice versa, at a distance, without any mediator being in between them. So this is what's so scary, that they give you these explanations, and people just believe, and they just swallow them because they come from PhDs. They say, well, he studied at the university, he must know. I don't care where he studied. I mean, if he's going to tell me that there's nothing in between these two objects, this one affects that one over there, well, we got two choices. Again, we either put spirits and do things with black magic, or we have to assume that there is a physical object that we can't see or touch. Okay, so those are the two choices. You have no other choice. Okay, another experiment that shows that quantum also does magic, okay, without objects, is this one. They say, look, particles can be at two places at the same time, and it can be excited and not excited at the same time. And how can you understand this? How can a particle be at two places at the same time? So they have all these explanations, and we have to assume that quantum is simply not a rational theory, because these are their physical interpretations. And again, they do it all with magic, and they do it all with ghosts and goblins, spirits, acting in between two objects. And it's like people have gotten so used to it, they don't even question it anymore. They say, well, quantum has been proven because otherwise you wouldn't have a computer. That works, right? So that's the answer you get, the kind of answers you get. Okay, here are the three possibilities, at least today. We used to have only two, now we have three. Okay, you have the particle hypothesis, you have the wave hypothesis, and now we have the rope hypothesis. We have three versions of what light might be. And the first question I've got for you is, here you have particles up there, okay? Why can't those particles travel faster? Why can't they travel faster than light? Why can't they travel faster than 300,000 kilometers per second? Okay, that's the question. Same for the one-way waves. No physical object called wave, but let's concede that. Let's forget about fighting that issue. Why can't the wave travel faster? What prevents the wave physically, right, from traveling faster? Do you have an answer for that? Can you think about that and give me an answer? Okay, and so here you have, again, the quantum versions. Okay, let's see. In the case of the rope, I don't know what happened here. Oh, I think it's this one. Hold it. See, here you have the particles and the waves. And the question is, here you have different speeds for the particles. Let's assume the one on top is traveling 300,000 kilometers per second. Why can't these particles travel faster, like the ones in yellow there? And how about the wave? You have a wave that travels slow and another one travels fast. Why can't we travel faster than light? And here on the right-hand side, you see why we can't, under the rope model. The rope model explains quite well that frequency is inversely proportional to wavelength. Okay, if it's inversely proportional, it means that the velocity of light is constant. All we're changing is frequency in exchange for wavelength. Under the rope model, it's link length versus the number of links. Okay, and so now we have an explanation for why the velocity of light is constant and why you cannot travel faster than light, because all you can do is increase the frequency at the expense of wavelength and vice versa. That's the situation. Okay. Okay, so we don't have an explanation from quantum mechanics. Let me get rid of these here. And we do have an explanation under the rope model. That's the main point. Okay, so someone asks, He says, give me a second here. Says, what's the earliest instance of c equals frequency times wavelength that you have found? I can't seem to find the innovator of the equation. It's an important question. It's an important question because it's so hard to find this type of information, one. And second, because no mathematician is specifically aware of this equation, c equals frequency times wavelength. I mean, they're aware of it, but it's like no one pays attention to it. They don't ask, why is that the case? Why does frequency exchange with wavelength? Why did Einstein say that light travels no faster if you throw the ball, if you throw the photon ball from a moving train, why don't you add the speed of the train to the speed of the photon ball? That was the issue. And they have no explanation for that today. Under the rope model, you do have an explanation, but nobody's familiar with this equation. It's not imbued in the minds of mathematicians at all. They heard about it, maybe they forgot about it, but they don't care about it. Okay, and so yeah, this is the history. Okay, just for your sake of your interest, right? These were the people who worked on the wave equation. D'Alembert, Euler, and Bernoulli. They were two Swiss mathematicians, and all these people, Lagrange and Maxwell, they all worked on the wave equation. Okay, but it was all math. There was no attempt to try to make sense of it from a physical point of view. That's where the problem was. And so it doesn't really matter who came up with it and how they discovered it or what math they did behind it to justify it. The point here is that we have this equation. We're all aware of it today. Nobody pays any attention to the equation. No one tries to explain it, of why it's the case. And for the first time, we do have an explanation. We're saying, if you take the rope, all you can do is, if c is equal to frequency times wavelength, in other words, c, little c being the velocity of light, 300,000 kilometers per second, all you can do is change the number of links for the link length. And here you see it. There's the magic trick. The links became longer and you have fewer links. So we can explain that equation, which is the equation of a rope. There's no other entity that can simulate that equation. So if you want evidence, well, for those people who like evidence, who think evidence is part of science, there you have evidence. Try to explain why that's not the case. Okay, thought I had a glitch there. Okay, so what are the conclusions? Let's see if we can move on to them. If I can get it up here. Okay, conclusions. Mathematical physics thrives on irrational language. Okay, they move the mass, they transfer the energy, they also transfer information. Very scary stuff. Mathematical physicists propose irrational physical interpretations simply because they can't see or touch the invisible, intangible mediators. Okay, so they can't see the mediator of light, and so they put particles in there, for example, but then they don't explain why light cannot travel faster than 300,000 kilometers per second, because there's no reason not to. Why can't the particles go faster? Why are they limited, physically limited, at 300,000 kilometers per second? Under the rope model, it's very easy. One frequency exchanges with wavelength. How do you explain that with particles? So clearly the particle hypothesis, meaning the quantum hypothesis, is irrational. We cannot explain anything with it. Okay? And as an object is not that which you can see or touch, which takes the mathematicians to the lab. They're trying to see and touch that which is invisible and intangible. Okay? An object is that which has shape, and it doesn't mean that you can see or touch it. So there's no use in going to the lab. You can stay at home and just try to visualize, think, and you'll reach your answer not by going to the lab. You'll do it with your brain. Okay? And quantum particles and waves are not objects for the purposes of physics. And the quantum particles are the zero-dimensional point particles, remember. That's not an object for the purposes of physics. It's a concept, not even a rational concept, but it is a concept nevertheless. And the electromagnetic rope explains the constancy of the speed of light, which quantum cannot. Okay?